There are an estimated 200 billion galaxies in the observable universe. Each one holds hundreds of billions of stars. Many of those stars have planets. Some of those planets sit in the perfect zone for liquid water, for life, and yet, in all that space across all that time, we have found nothing. No signal, no structure, no sign that anyone else is out there. This is the Fermi Paradox, and the answer might be the scariest thing in science. In the summer of 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos. The conversation had drifted to UFOs, and then to the possibility of faster-than-light travel. And then, almost as a joke, Fermi asked a simple question. "Where is everybody?" It sounds casual. It wasn't. Fermi had just done the math in his head, and the math didn't add up. The Milky Way alone is about 13 billion years old. Even at a fraction of the speed of light, a single civilization could colonize the entire galaxy in 5 to 50 million years. That sounds like a long time. It isn't. Not on a cosmic scale. 50 million years is less than half of 1% of the galaxy's age. Which means, if intelligent life is even moderately common, someone should have beaten us to it. Someone should already be here. Or at least, we should be able to see the evidence they exist. We don't. Not one signal. Not one probe. Not one Dyson sphere blotting out a star. Just silence. And that silence has a name. The Fermi Paradox. The gap between how likely life should be, and how alone we actually seem. So, where is everybody? There are only a handful of possible answers, and none of them are comfortable. To understand why the silence is so strange, you have to understand just how much time the universe has had to work with. Our sun is about 4.6 billion years old, but some stars in the Milky Way are far older, some over 10 billion years old. Stars that had planets and possibly life billions of years before Earth even existed. Think about what that means. If even one of those early civilizations developed space travel, even slow, sub-light speed travel, they would have had a 10 billion year head start on us. 10 billion years is enough time to cross the galaxy hundreds of times over, using nothing but self-replicating probes traveling at a tiny fraction of the speed of light. This isn't science fiction speculation. It's basic orbital mechanics and patience. A probe that builds 2 copies of itself every time it reaches a new star system would spread through the entire galaxy, all 400 billion stars, in roughly a few million years. On a 10 billion year timescale, a few million years is nothing. It's a rounding error. So if intelligent, technological life is even moderately common, if it's happened even a handful of times across the galaxy's history, we should be surrounded by evidence. We should see megastructures around distant stars, strange dips in starlight, radio signals, something. Instead, when we point our telescopes at the sky, we see exactly what we'd expect from an empty universe. Stars, gas, rock, silence. That gap between what the math predicts and what we actually observe is the entire paradox, and it forces one uncomfortable question. What happened to everyone else? There are 5 explanations that come up again and again. Some are hopeful, some are terrifying. Let's go through them. 1. We're early. Maybe the universe just hasn't had enough time yet. Heavy elements, the carbon, oxygen, and iron that life needs, had to be forged inside dying stars and scattered across space before planets like Earth could even form. That process took billions of years. It's possible complex life is only now becoming common. Not because we're special, but because we happen to be one of the first. If that's true, it means we're not late to the party. We're early guests standing in an empty room, waiting for everyone else to arrive. 2. The Great Filter. This is the one that keeps scientists up at night. The idea is simple. Somewhere between lifeless rock and galaxy-spanning civilization, there's a filter a near impossible barrier that almost nothing gets through. Maybe the filter is behind us. The jump from simple to complex cells, which took Earth nearly 2 billion years and may have only happened once. Or maybe the filter is ahead of us. Maybe every civilization that reaches our level of technology, nuclear weapons, engineered pathogens, artificial intelligence, eventually destroys itself. If the filter is behind us, we're safe. We already beat the odds. If it's ahead of us, we are about to find out why the universe is so quiet. 3. The Dark Forest. This one comes from game theory, not astronomy. Imagine the universe is a dark forest at night. Every civilization is a hunter, and every hunter has the same 2 rules. Survival is the only priority, and you can never be sure if another hunter is friendly or hostile. In that situation, the safest move isn't to announce yourself, it's to stay silent. And if you ever detect another hunter, to eliminate them, quietly, before they can do the same to you. Under this theory, the universe isn't empty. It's full. Everyone is just hiding. On purpose. And every civilization that broadcasts its location loudly, the way we've been doing since the 1930s, is playing a very dangerous game. 4. Rare Earth. Maybe the pessimists have it backwards. Maybe it's not that intelligent life self-destructs. It's that intelligent life almost never happens in the first place. Earth had a highly specific set of conditions. A large moon that stabilizes our axial tilt, a molten iron core that generates a protective magnetic field, a Jupiter-sized planet nearby sweeping up dangerous asteroids, plate tectonics that recycle carbon. Take away any one of those, and Earth might be sterile. If that combination is rare, genuinely rare, one in a galaxy rare, then the silence isn't a warning, it's just math. We got lucky, and almost no one else did. 5. They're already here. We just can't see them. The least comfortable option. Maybe advanced civilizations don't expand loudly. Maybe they don't build visible megastructures or blast radio signals into space. Maybe, to a civilization thousands or millions of years more advanced than us, we simply aren't worth contacting, or observing, or interfering with, the way we don't leave diplomatic messages for ants. Of all these explanations, one keeps coming back to scientists more than the rest. The Great Filter. Because here's the problem. We don't actually know if we've already passed it, or if it's still waiting for us. Look at the last 100 years alone. We built weapons capable of ending civilization in an afternoon. We're engineering pathogens in labs. We're building artificial intelligence systems we don't fully understand, and racing to make them smarter, faster than we're racing to make them safe. If the Great Filter is ahead of us, not behind, then the silence in the sky isn't just an absence of aliens. It's a warning. It would mean that every civilization, everywhere, eventually reaches this exact point. The point where their technology outpaces their wisdom, and almost none of them survive it. Not because of some external threat, not because of aliens or asteroids or cosmic disasters, because of themselves. If that's true, then the Fermi Paradox isn't really a question about them. It's a question about us. And somewhere out there, if anyone is still listening, they might be watching Earth right now, wondering the exact same thing we are, wondering if we're about to go quiet too. So, which is it? Are we early? Are we alone? Or are we simply waiting our turn to go silent, like everyone before us? Nobody knows for certain. But in the next video, we're going deeper into the theory that scares scientists the most, the Great Filter, and why some researchers think we may have already passed the hardest part, or are about to face it. If you want to know where humanity might really stand, subscribe, and we'll find out together.